Let us return to this correspondence, the actioneer's correspondence. It is defined in this set, takes values in the unit sequence. First of all, for every z in this set, it is clear that this set is non-empty. Why? Because by Weierstrass theorem, you are maximizing a linear function p times z with respect to p. Since every linear function is continuous, by applying Weierstrass theorem to delta, which is a compact set, you are sure that there is at least a point of maximum. So this set is, generally speaking, non-empty. It is clear, moreover, by another time, by the continuity of inner product p times z, that f of z is compact and complex. Note that all the properties of Kakutani's theorem are appearing. In other terms, our correspondence f has non-empty, compact and complex values. It remains to prove that this correspondence is apparently continuous, and this result must be proved. Take any sequence z of n of excess demand vector in this set, which converges to a certain z also in this set. And take a sequence of price system Pn in delta such that for every n in n, Pn belongs to z, to f of z n. In other terms, this sequence of price system is written this way. For every vector z n, Pn is one of a price vector which maximizes the value of z n, according to our definition of a correspondence z. Is it clear? But since Pn takes values in delta, which is a compact set, without loss of generality, we can suppose that Pn converges to a certain P in delta. Generally speaking, Pn could be a non-convergent sequence, but you can extract from it a subsequence which is convergent to a certain P in delta. This by the compactness of delta. So, without loss of generality, we can suppose that Pn itself converges to some P in delta. We must prove simply that Z, the limit point of the sequence Zn, is an element of f of P. If we prove this result, we obtain apparent continuity. Well, let us suppose that, the converse P belongs to f of z. Let us suppose that this is not true. When you have a limit point z, P is not a price system which maximizes the value of z. This means that in delta there is another price system P prime such that P primes times z is larger than P times z. Simply, if P does not maximize the value of z, there is at least another another price system P prime, which gives to Z a value which is greater than the value given by P. But by continuity, since Z converges to Z, there exists a star in N such that for every greater or equal to star, P prime times Z must be larger than P times Z. This simply by continuity of a linear product. If in the limit P primes gives to Z a larger value than P, for sufficiently great, the same thing would be verified also for Z and P, because P converges to P, Z converges to Z, Z converges to Z. But is it possible with inequality? No, because when you are considering Z P by assumption is the price system which maximizes the value of Z. And here you have another price system which associates with Z an higher value. This is impossible. And so we conclude that the correspondence F is apparently continuous. In reality, this is a simple result because F is defined by means of a linear function. Not so difficult to disprove. However, I shall repeat over demonstration. We must prove that the correspondence F of the auctioneer's correspondence F is apparently continuous. So take any sequence Z of excess demand vectors which converge to certain Z, and takes another sequence P such that for every in a large N, P is a vector, the price vector, which maximizes the value of Z. Without loss of generality, since delta is a compact set, we can suppose that the sequence P in turn converges to a certain price system P. So in order to prove apparent continuity, we must prove that this limit price system P belongs to the F of the limit point Z. In other terms, that P maximizes the value of Z. Suppose that this is not true. P does not belong to F of Z. But this means that there exists another price system P prime delta which associates with Z a value which is greater than the value associated by P. But by continuity of a linear product, there exists a sufficiently high index N star such that for every N greater or equal to N star, also P prime times Z N is greater than P times Z. Why? Because Z converges to Z and P converges to P. By continuity, from a certain index N star, also this inequality should be verified. But this is impossible because when you consider Z P is the vector which maximizes the value of Z. It is impossible that there is another vector which associates with Z a higher value than P. So our correspondence F is upper and continuous. Another vector.